Why does time stop flowing when an object reaches the speed of light? If you've heard of time dilation, then you definitely know that the closer you get to the speed of light, the slower time passes. But have you ever wondered what would happen to time if we accelerated to exactly the speed of light? According to Einstein's theory of relativity, at the moment you truly reach the speed of light, your time would completely freeze. To understand this revolutionary conclusion, we first have to look at what makes the speed of light so special. From high school physics, teachers tell us that the speed of light is the universe's absolute limit, like an invisible wall you can't break through. Most of us obediently accept that rule, but very few people actually question the logic behind it. Is there really some invisible hand out there stopping us in space? The truth is far crazier than anything in the movies. Einstein argued that if you truly approached the speed of light, all the rules of the universe would collapse. You would no longer be bound by time. It sounds like a crazy theory, but to keep you from escaping, the universe has built a closed, incredibly tight chain of logic. To decode this secret, we can't just stare at Einstein's equations. We have to go back to the 17th century and see how humanity first uncovered the secret of the speed of light. The story begins at the Paris Observatory in 1676. Back then, most people believed light traveled instantly. When a star was born, its light would immediately flood the entire universe. But there was a Danish astronomer named Ole Roemer. He spent many nights observing Io, a moon of Jupiter, and discovered a strange phenomenon. When Earth was far from Jupiter, Io's eclipses seemed to arrive late. When Earth was close to Jupiter, they arrived early. At the time, many people dismissed this as an observational error. But Roemer had a bold intuition. What if light needs time to travel through space? This was the first time humanity realized that light wasn't a ghost that arrived instantly, but a messenger that takes time to move. Even though Roemer's calculations weren't very accurate back then, he opened the door to modern physics. Light has a speed, and if light has a speed, relative to whom is it moving? That question triggered a major panic in 19th century physics. Scientists thought that if light is a wave, then it must need a medium to propagate, just like water waves need water, and sound waves need air. They gave that hypothetical medium a beautiful name, ether. People once believed Earth was gliding through an ocean of ether, like a boat drifting on a river. Downstream, light should be faster. Upstream, light should be slower. To find the ether, in 1887, two great scientists, Michelson and Morley, carried out an extremely precise experiment, but the result made the entire physics community break into a cold sweat. No matter which direction light traveled, whether you ran with the light or against it, the measured speed of light was the same. It didn't change at all. This violated Newton's idea of absolute space and absolute time, which had stood for centuries. When everyone was confused, as if the whole building of physics was about to collapse, Einstein, only 26 years old at the time, looked at the unchanging speed of light and proposed a shocking idea. If the speed of light doesn't change, no matter how you measure it, then something else must be changing. To protect the speed of light as a universal limit, we have to sacrifice the two things we once believed were the most solid: time and space. This was the birth of special relativity. Einstein said that when you try to chase a beam of light, for you to still measure light at 300,000 kilometers per second, the universe has to distort your time. It's not that your clock is broken, time itself is stretched. The faster you run, the more your time is forced to slow down. The speed of light stays the same. This isn't just a mathematical gimmick, a crazy compromise the universe is forced to make. Now let's return to the original question. What happens if I truly reach the speed of light? Imagine time as a budget. The faster you move through space, the less budget is left for time. When you accelerate like crazy and get close to the speed of light, your rate of time is compressed and slows more and more. Hundreds of years could feel like a single moment to you. And when you truly reach the speed of light, your motion through space has consumed the entire budget, so the budget left for time becomes zero. That means, for a photon, leaving the surface of the sun, traveling about 150 million kilometers, and then hitting your retina, to us, that journey takes 8 minutes and 20 seconds. But for the photon, the whole trip takes no time at all. Departure and arrival happen simultaneously. In the world of the speed of light, there is no past and no future, only an eternal present. The very concept of time collapses there. That's why we can never reach the speed of light, because mass is the final key. When you get close to the speed of light, your mass becomes infinite, and it would take infinite energy to push you. It's as if the universe is telling us, extremely, that matter belongs to time, while light belongs to eternity. We are stuck in the slow lane below the speed of light. But maybe that isn't such a bad thing, precisely because we can't reach the speed of light. Time passes through us and we can experience growing up, aging, memories, and hope. The speed of light is the key to the universe, but it's also the umbrella the universe grants to existence. It keeps us in the flow of time so we can live a complete life.